Hello. Similar to what I did after the first midterm, I will go quickly over sketch solution for the second midterm questions. So now you get your exams paper, so you can compare your answers with my answers. If you have any problem, like something that you're not sure how I graded them, you can reach out to me. So what I will do now is to go quickly over the solutions for the second midterm. So let's get started. So in the first question, and this one is fairly easy question. There's nothing anything difficult about it, except maybe the trick here is just to recognize that, or not a trick, but to know that you are given I. But you can move from I to delta because this is continuous case. So delta is, remember, it's ln 1 plus I, or 1.05. And the second thing, you're not giving them mu, the force of mortality, but you're giving the expected life, or life expectancy. So this one we know it's 1 over mu, so mu will be 1 over 60. Let me write it. So mu will be 1 over 16, and it will be 0.625. Where's my calculator? 1 over 16, which will be 0.625, right? So this is your mu. But now the question is, which is straightforward, right? Because this is deferred annuity. Deferred annuity, this one, deferred for 20 years, is simple because now you have 20EX, then AX plus C20, the general rule. But this one here is because it's exponential distribution, so this one will be E delta plus mu multiplied by 20, then everything is multiplied by, mu over mu plus delta, right? All you need to do is to substitute. I didn't put the numbers here because it will take lots of effort to write so many decimal. It's easier just to block them in your calculator all at once. So I will start with delta, which is, we said it's 0.625. Then I add to it ln 105. So I got then the 11.1%. Then I multiply it by what? By 20 years. So now this will be my exponential, so E minus this, then multiplied by mu, which is 0.0625, divided by mu plus ln 105. If you do that, you would get, this is the answer I got. So this will be all at once. You do it in your calculator. Where is 0.60614. And let me check with my answers. It's correct. So this is the first question. So the first question is fairly easy. There is nothing hard about it. But let's add the second question. I'll see what's the second question. This one I try to, like make it easy, not the hardest one. I could have made the annuity or other things, it will take more time, but this one is also fairly easy. You have the distribution, the life table, the illustrative life table, you have it with you. It's with I 5% and assuming UDD. The first thing I always is write the equation and see what I have and what is missing. So this one is equal to 40, 20 plus 20 E40. And 20 E40, if you have your life table, it's just like you can right away, well, let me write it here. This one from the life table directly is 436663. So now this one is what we need, but this one is continuous. The life table does not give us a continuous, but we can move from discrete to continuous. So let's calculate this one first, the discrete. The discrete for A40, that without the bar, for 20 years, there are several ways. The life table actually give you life table, maybe I can put it this way. It gives you the life table this. It gives you this plus 20E40, which we calculated it. This 20E40 we already calculated it, it's here. 0.36, not calculated it, got it from the life table. This one is not given. This one from the life table also, you have A40 for 20 years. So we have the term, the endowment insurance for 40 years old. For 20 years, I have this one to be, not to make a mistake, 38126. Now, if you have your calculator, because now you can get 38126, you subtract from it 0.36663. So this one now, you can get this one to be very good. Very good, because now this one now we can take on the side. Now we need this one, the A40 with bar, the continuous case. And you know that this is you use UDD, uniform distribution, so it will be I over delta, the A40 one without bar, and the A40 without bar, which we calculated it, 0 0 1 4 6 3, right? We already calculated it from here. Now I 5% divided by ln 105. So let's calculate 0.5 divided by ln 105 and then multiply it by our reference 04163. So I got this one to be and this is the A40 continuous. So now once you do that, you're already almost done. Once let me see, did I get that right? Correct? Yeah, correct. So once you do that, now you add 83666 plus, and this the answer will be for us and there, as I mentioned, there are different ways, you know, might get little discrepancy while you solving this one. What I did here, I calculated A40, you know, I calculated A40 this way, this one, but you can also alternative way, and some of you did it that way, most of you actually. A40 20 is this one, you can make it A40 minus 20 E40 A60. Both of them, they will give you the same answer for this one. This one will be a little bit more 6.5 at the end. So both of them they will give you, but the answer, you know, like for 3 digits should be for 4 digits should be that that number. All right. So it's not hard, this one, if you know what you know what you are doing. It's not hard one. Now let's look at another question here. We did the question 2, let's do question 3. Okay, let's look at question 3. So question like this, it's also you start with what you have. What you have here is the variance. The variance, you just put the what the variance for life annuity, continuous life annuity, if constant mortality, because mu is constant. If mu is constant, then this one we can use the, you know, like the constant force of mortality formula directly. So this one will be 1 delta square 2ax bar minus ax, the expected value, raised to 2. But if you do that, this should be very straightforward. Once you do that, it's easy. Why? Because let's take it here. Now you have delta to be 4k, so 1 over delta square is 1 over 16k square. Right, you see what I did here. But what is 2ax? This is equal to, if you remember the formula for this one, mu over mu plus 2 delta. But delta, mu is k, and k, 2 delta is 8k. If you cross out the k's, 1 plus 8 will be 1 over 9. So 1 over 9. Similarly, if you do ax, it will be mu over mu plus delta, which is k over k plus 4k. And this minus, and everything here should be equal to 100 over 9. Yeah, so let's do the calculation. 1 over 9, subtract from it 0.2 square. Now you have 100 divided by 9, and now divided by this. Up to this point I got 116k squared, just to do step by step, is equal to 156.25. Now take the 6 to the other side, multiply by 16, flip it over, so k square will be 1 over now take, so, or in other words, k square is equal to, now take the square root of it. You will have minus and positive, but cannot have negative force of mortality. Force of mortality should be positive, even if it's not given in the question. Is always force of mortality will be positive. You know, there is no one will be resurrected. So it's so now this one you raise it to 0.502. Force of mortality is, you know, like you start with a cohort of people, they decline over years, so it should be the only the positive value. We drop the negative value, right? Does that make sense? So let's take another equation. So k for us is equal, just to double check, yeah, it's 2%. Now let's take another question. Let's take question 4. Now question 4, I told you in some of the videos that those are the kind of questions I like. It's just like it's important to visualize them. If you don't visualize them, it gets harder. Let's start, you know, visualizing this relationship. We have IA35 and IA36. Let's start with IA35. Let's have a line here, 35, 36, 37, maybe we'll add another one, 38, and then, so I35, it gives you 0 here, 1, 2, oh, because it's increasing, 3. Right. Now let's look at I36, the question asking us for I36, because 35 is evaluating here at I30, sorry, IA, I mean 36. IA36, it gives you 0 here, 1, 2, and so on. Now what else we have? We have A35. A35, the year of evaluation is here. The year of evaluation for A35, we are here. It gives, if death occurs in the like 0 here, so it gives 1 here, 1, it's not increasing here. Now if you look at the 3 the blue, the green, the black one, if you look at them together and try to connect them with each other, what you would see that this 1 plus 0 plus 1, no, sorry, let me see what we have here. Yeah, what you see, 1 here, 2, 3, right? We see that. So now what we can see is, if we relate them to each other, we see these give you this. If you add this, it gives you this. If you add this, it gives you this. Are you following me? So this is easily to write it IA 35, this is the biggest one, equal to, well, A35, the black value, plus the green value with one issue here, that 36, the year of evaluation is 36. We need to bring them, all of them, to 35. So if we bring this to 35, it means that we need to have P35 and V, the discounting factor, because this one is at different at later years, so we need to discount it back, actuarially discount it back. So this is the equation that is very important to recognize. Once you do that, it becomes mechanical. Let's see what we have. The question asking us for 36. So this is the question. What is 36? This one is given. This one is given. Do we have V? We don't have V, but we have P. This one is given. We don't have V, but let's look at V. Let's see what we have here. Oh, we are given A35-1, and this is endowment. So what I mean by endowment, somebody 35, 36. This, you can do it mechanically, you know, write the equation, or we can conceptually get it. So here, if the death happens here, at the end of the year, you'll get $1. But if you survive, you're gonna get $1. So it seems the $1 we are getting it anyhow. If death happens in the year, you get $1 at the end of the year, or if death does not happen, you will get $1. So the $1 is certainty. You're gonna get it. So, but we need to discount it back, right? So A35, it's certainty. There is no probability of it. It's gonna happen. It's gonna happen anyhow. The $1, if death happens, gonna happen. If death does not happen, you're gonna get the survival. So if death occurs, or if you survive, you get the $1. So this is V. But if you just not sure about it, you can just always write, you know, VP35 plus, sorry, Q35 VP35. If you do that, it will give you V, because yeah, I mean, if you do the math, but you don't need really to do that, because it's conceptual. You can get it. So we know V is what is given here. So we got everything we wanted. So we have A35. What is A35? 13 plus P35 9964.9964. Now V, which we already just said what it is, it's 9434. And what we wanted here is IA36, and I said IA35 is given to us 371. Let us just plug in these values in our calculator and see if we can get that. So 3.71 minus 0.13 divided by 0.9964. Let's divide it by 0.9434. I got this number. Hopefully I got it correct. 38085. Yeah. So then if you do the calculation, then and A36, what I got is 38085. Easy question, doesn't take lots of time. It's just the trick for it is to visualize it. Once you visualize it, it becomes clearer. What question now? Question 5. That's another easy question. It's again, it requires us to visualize what is the question here. So it's very easy. We have uniformly distributed. We are given the continuous. We need to find the discrete. So let's start. This one. It's continuous, but the question is about discrete. So let's solve it. Let's make it discrete, so it helps us later on. So the continuous is always equal to 1i over delta the discrete. Right. And we have I, we have delta is 1 over ln. So this delta always, I'm not 1 over, I mean ln 105. So now let's do that. We have I, which is 0.5 divided by ln 105. Then flip it over, multiplied by 0.185. So what I got A36 to be right, so that's what the first one I got, right? 2,4. Now what we need to do, but the question is asking about 35. You 35, 36, it's easy. A35 and A36. How we can relate them? There is only missing 1 here if death happens here, but then we can equate them. So A35, from the line here you have 1. If death happens here, VQ35, or if you can take the A36 but bring it back, VP35 A36. Right. So let's see what we have. We have the A35, this one, we already calculated it. We have the V already, V, and we have P35 is the opposite, 0.99 plus 0.01 V. Let's do that. So if you do that, it's easy. So A35, so this is like 2-minute questions, not more. If you know what you're doing, it should be 973. This is really 2-minute question. So we did 5 question now. All right, so let's take now the next question. I think question 6. So let me just upload it. Question 6. Oh, not 6. Which question? Yeah, question 6, correct. So let's look at question 6 now. Question 6 is not really difficult. It's just we looking for the pure endowment insurance, but then we change the interest rate. So let's start with maybe we can draw a line. So you have 60, 61. Are you following me? 62, 63. So if death happen, let's look at this A63. If death happens here, then we have V at the end of the year. Excuse me, Q60. But if death happens here, then we have V2, Q60. Sorry, we need first to survive to 60, Q61. Now, if death happens here, well, we need to remember there is no 1 here. So you're gonna get 1 if death happens, or you're gonna get 1 if death did not happen. So at the end of year 3, which is V3, you're gonna get the dollar regardless, death happens or not. So if we only survive here, we're gonna get the dollar here regardless. So you only need to do 60 and P 61. And let's put what we have. We have this, we have this, we have this, this not, this not. So let's plug in what we have. We have A63. Let's keep V as is. It's easier to put it in the calculator the way it is. Q6 is 0.1% plus V2 0.99. Q61 is what we're looking for, plus V3. Let's make it P60 and maybe to keep one unknown, which is Q61, just because then we have one unknown. Now let's do some calculation. So we need to solve for Q61. You know what, I can give you the answer because it's not waste time. All we need to do, we have one, it's like X, your X, that everything else you have it. P60, actually this you can write it 0.99, not to waste time on this one. So because I did calculate it before and I got Q61. If you solve for this Q61 or P61 will be 1 minus it, which is 980. Once you solve, you plug in your values. Now we need to find what if interest rate change. Now it's not 5%. No, now we need to redo with 4-5%. So now we change the interest rate to 0.4%. Was it 4.7? 4.5. You use exactly the same formulation here, but you plug in the 4%. So now we're looking for the same question. A60 for 3, you plug in all the values you have, but with the new interest rate. If you do that, just the same thing, and now you have this, all you need to do is just you plug in your new interest rate, and this should be 0. And this is what you should get, right? And it should be just, sometimes it's good to double check. This should be little bit higher than this one, little bit. Why? Because now you lower the interest rate, it means the value is it's higher. When it's discounted, it will not eat so much from the discounting, right? So this is the answer for this question. The same thing, all you need to do is just to replace the V with the new V that uses the new interest rate. And now let me go back. Now it's getting interesting here. Let's see this question. Not really. It's very easy as well. Right. It's very easy also, this question. If you do the calculation slowly, you should be able to get this question easily. Just think about it. What we have, we need to find a X20. I would rather I think the only difficult thing is that there is no accent here, so there are no 2 dots on top of it. So the best thing is to calculate the 2 dotted one, and then you can sort it out. So let's see how we can calculate this one. Let me just put this here. What we have here is, we need, firstly, like the roadmap for this one is to find AX20. If we found this one, then we go to AX20 and then we go to AX20. So this is the roadmap for question like this. So let's start with what we have here. AX is equal to AX120 plus 20 EX multiplied by AX plus C20. This is the equation. So AX is 0.28. You add this is what is missing, AX20. This is what missing. Then 20 EX. It's this one can be written 20. Can be written 20 EX also. Same logic. So it's 0.25. AX plus 20 is 0.4. Now this will give us this guy here equal to 0.28 minus 0.25 multiplied by 0.4, which is 0.18. So this is the first one. Now we got, if we moving in our map, we got this one. Now how we can move from this one to the annuity? It's easy. The annuity X for 20, 1 minus, and we need to be very careful here, AX 20 divided by D. Wanted you to be very careful because there is no 1 here, right? So we need to be very careful here. So we need now to move from here to here. If there is a step that actually before that we need the one without 1, right? So if this is the one with like the term insurance is 18%, then this one will take us to the AX20, which is the term plus 20 EX, which is equal to AX 0.18 plus 0.25. So this is easy because now we can solve this one. 1 minus 0.43 divided by D. What is D? It's I, or 0.5. Let me make sure that the interest is given 5%, right? So 1 minus 0.43 divided by 0.05 multiplied by 105. So I got this one to be 11.97, and it's still not the answer. We need to be very careful about it because this is the one with accent, the do. We need to move from this one to the regular one. But let's draw a line here because we need to be careful about this one. Let's draw a line. So we have 0, 1, 19, 20. If you have the one with accent, I meant X. If you have the one with accent, this will give you 0 here, 1, oh sorry, it will give you 1 here at the beginning of the year, 1, 1, 0. But the question is asking us the one without the 2 dots on top of it. This one will give you 0 here. Let me use different color. Give you 0 here, 1, 1, 1. Are you seeing this relationship? So let's try to set them in one equation. So this one, firstly we'd recognize that there is 1 here is problematic. So let's add the first one that is not there. Then we add to it, right? Because these are equal here. The other problem is here. Now this one has extra 1 but at the end, so we need to subtract it. Subtract, and what is this one? You bring it back, is 20 EX. I usually don't memorize it. I give it to you in the course like this one. I give it to you in another in where we were working on this exercise, but I don't memorize it. Don't memorize it, just visualize it, and every time you can derive it quickly. It doesn't take time. So let's see what we have. We have 1197, this one, minus what's 20 EX, which is given to us as well, 0.25. No, I meant, sorry, I think this one, when we calculated here 9, there's just 7, was it 97? Just let me make sure. Yeah. And now here what we wanted. So 11.11, we subtract 1 from it, we add 0.25. Then what you will get, the answer for the question is, and this should be less because it gives you, like this one gives you the payment earlier, so this one should be less than that one. Let me make sure that I got the correct answer. It should be correct. Which question? Yeah, it should be 1122. Very good, very good. So so far it's not really hard exam. It's just like you need to be focused. So many things going on, but you need to be focused. Let's take another image here. What question now? We did the question 7. Let's do question 8. This question is require a little bit of work here. Similar, we need to remember that we are not looking for, oh, what is this? Sorry. So we need to calculate the accent but semi-annual annuity that is payable at the beginning of the year for somebody age 69. Very easy. All we need to do is to follow slowly to find this question. So what we have 70, but we need to get it back to 69, and it's not continuous. We need to get the discrete. So the discrete from this one, A70, the discrete is equal to I over delta the A70. Right. I mean the continuous is this way. So this one is now 0.53 is equal, what's I? 0.6 divided by ln 106 of A70, because we're working on discrete, so let's move this one quickly to the discrete case. So the A70 is first one now, 0.53 multiplied by ln 105 divide, oh, not 106, sorry, and my calculator I insert 0.53 multiplied by ln 106 divided by 0.6. So what I got for 70 is 0.15471. So the first one is to get this one correctly. Now let's see what we need to do. Now we need to get this one to the 69. How we can get it to the 69? That's important here. How we can get this one to the 69? Simple. The A69, if death happens in the first year, you get V, but death happens the first year. Or death does not happen the first year. It means that we're gonna get the, if death does not happen, it's surviving 69, you get V, but you get A70. Up to this point is easy because we have 0.15471. Let's see what we have. We have 0.97. We have V at 6% we have 0.03 and then V. Now if you compute this one, then A69 up to this point is I got this 993 4, like I got this one here 9931. So easy, so far so good, nothing difficult here, but remember we need that accented, the one with accent and with 2, the one with 2 dots on top of it with the number 2 to say that it's payable semi-annual. But this one, now we need to go from A69 to why we are doing this, because if we want to know where we're heading here, this one is equal to 1 minus A269 D2. We need to remember, so we need this one. So all we're doing slowly to get this one. So how we can get A69 with 2? Remember, this is, if you go back to your note, I with I to 2. A69 with interest is 6%. If it was interest 5%, this formula here we find it in the life table. But interest 6%, we cannot use the life table. Everything is different now. So now let's look at I. I is 6%, but I2, it's easy, to 1.06 raised to 1 over 2 minus 1. This is the formula. What's A62 multiplied by 49931? Yep, if you do that, I'll do it quickly. 1.06 raised to 0.5, subtract from it 1, now multiply by 2, and now multiply by 4. I got this number. So this one will be 0506689. We're almost there. So let's go back to our question here. What was the question? The question is to find what is A269, and we said this is the formula. So now this one we got this one. Now we need D2 to 2, which is easy. I mean, you can calculate it in the same equation. So this one, 1 minus what we found just now, divided by T, D2. D2 is T, if you remember, 1 minus V to 1/2. If you do this, let me do it quickly. I'll do the D. D to 2 is 1 minus If you do that, your V will be 05742. One minus. I keep everything in the calculator so I don't miss any number. So this one, just for you to what you would get the answer for A269 to 69, was it? Yeah, 69. What you would get is this calculator, if you 859. It's a good question. It has a few built-in, concepts. So built-in concepts. So one question will ask you about multiple things, about conversion from many other questions. Right. So it's a very good question. Not difficult, but because there are so many little steps that sometimes you tend to forget one or two of the steps. But yeah, it's not a difficult question. Let's look at question 9. Question 9, we did something like this in the problem set, almost the same, but I removed the big payment. I kept it $1. It's easier because many students usually forget to square it, so I kept same thing, but I just removed that big payout to make it easier. So let's look at this equation here. So here we have a group 100 lives, X independent. Y is the present value random variable of the aggregate payment. So Y is equal to Y1 plus I2 up to 100 individual, right? This is the random variable for each one, but each one is actually an annuity. It pays $1 at the beginning of each year if alive. So it's a life annuity, the usual one. So for each YI for one individual, for one individual one person, the expected value of Y for one individual, this is easy because this is like a life annuity, right? It's a life annuity here. So it's a life annuity. What's the expected value of life annuity? We know it. You have AX, so it's easy. It's 1 minus AX divided by, and given that this is discrete, we divide it by D, right? So it's one life annuity here. It's not difficult, right? So the expected value here, 1 minus 45 divided, what is the interest, is 0.5 105. If you do that quickly, 0.55 divided by 0.5, then multiply by 105. Oh, sorry, why I did that? 1155. So the expected value will be 11.55. This for one life. What about the variance of one life? Like for one individual, what is the variance? It's simple. It's 1 over D to 2 AX minus AX square. This is discrete case. And we have 1 over D to 2. What is 2AX? Should be given in the question. 22 minus 45. So I'll do it in the calculator. 0.22 minus 0.45 square divided. Now let's look at D. D is 0.05 divided by 105. Now raise it to 2. Now we take this guy here, 7715. So I got this one now. So this one now, the variance for one life is 7.7175. So you calculate for one individual the expected value and the variance. But now we need for the aggregate for Y, which is the summation of all the IIs from I1 to 100. For the whole fund, the expected value of Y, the aggregate for everyone, it will be 100 multiplied by the expected value of one individual, because these are independent lives. independent life, right? So we have 100 multiplied by 1155. Now variance of y, same thing, is summation of all the variances, summation of variance of yi, because they are independent and identical. So it's 100 multiplied by the variance. So what is the variance? We calculated it to be 77175. So the variance will be variance of the aggregate. But what is the question? The question is to find, using normal distribution, to find the size that needed to have 95% certainty you will be able to make the payment. So let's visualize it. Usually easiest ways to visualize it. So for the whole fund, we need to look at only 5% chance that you will not be able to have sufficient fund, but 95% is your fund is sufficient. So what is your fund here that you will be able to meet the obligation by 95%? So we need to look at Z, and the life table that is attached, not the life table, in the life table first page you will have the normal distribution, right? And we did question like this, so I assume it was easy. So you'd look at the end of it, right? So this Z here exceeded only by 5%. The value of Z that is only exceeded by 5% will be 1.645. It's something that we remember it because we use it a lot in statistics, but if you didn't remember it, it's easy because you have the normal distribution. So now the value of the fund, what is the value of the fund? But if it was the normal distribution this way, so we can move from normal distribution to any distribution is by adding the expected value of y, then add to it the z, 1.645, multiplied by the standard deviation for the aggregate y. So what is, we already calculated the expected value of y is 1155 plus 1.645. Now the standard deviation of the variance, standard deviation is the square root of the variance, 77175. Was it 75? It's an easy question, especially that we did one exactly similar to this one. So this one is very easy because we did exactly something very similar to this one. So if we take the square root of the total fund, multiply it by 1.645, we add to it 1155, and you will get 1200. So we need to have the fund of 1200. So if your value of the fund that you will have 95%, like you can cover with certainty of 95%, the needed amount to meet your obligation is this value, right? So it's really not hard the question. I would say this is easy, especially that we did exactly the same question with instead of 1,000 with $1. Now let's look at the last question. I think we did 10 questions. This question is a nice one, easy. Whenever you see the distribution normal or uniform, it's easy because the calculation is simpler. It just requires to test us our conceptual knowledge. So here we have a lottery. The lottery will have, let's visualize it. Let's visualize it. But before visualizing it, I hate to see, like a creation like this, E40. What is it? Let's calculate it. What is E40? It's 1 over mu. It's 1 over 0 to 50. So the life expectancy for somebody ages 50 is somebody's age 40 is 50. So now what we can change this language here, 40 plus E40, so 40 plus E40 is 90, because you already calculated this one. It's easier for us. So let's visualize the story here. The story that somebody age 40 will have a deferred annuity payable continuously starting with age 40 plus expected value, which is 90. So at age 90 we'll get a K paid continuously, right? So this is life annuity, deferred life annuity. But if death happens, or not death happens, if like here, so the deferred annuity plus annuity certain, there is no probability here. It's just, even if dying the first year, you would still get 50 years of annuity, worth of annuity. The estate will get 50 years of worth of annuity. Here it's A for 50 years multiplied by K. Here we can think about this one here is K multiplied by A, now 90. Does that make sense? What is the value here? The value is 10,000. It's given in the question. And we need to calculate what's the payment that is needed. So let's have K. So we have K. Firstly, you have annuity certain for 50 years plus K. But now this one is at age 90. We need to bring it back. How we bring it back? Well, it's actuarial present value, which is 50 E40 and multiplied by now the annuity at age 90. Once you reach this formulation, then it's easy. All you need to do, you plug in your numbers. You plug in your numbers, it's easy. So let's calculate 10,000. Okay, let's factor out the K. A59 is 1 minus, like it's easy, 1 minus, what is annuity certain is 1 minus E minus, what is our delta? 1%. Multiplied by 50 years. There is no mortality here because annuity certain here. Actually, we're factoring out the K, so it's okay, plus. Now 50 E40 for, now this is for we add mu plus delta, which is 3%, multiplied by 50. Now this is life annuity multiplied by 1 over 0.03. Now if you do our calculation, let's do that all at one step. You know, you don't need to. Let's start from this one. 1 minus E so first thing I got here to be 39. I keep it in the calculator, but just for you to compare your answer. I got for this one here and remember here everything is multiplied by K. Then K, if you solve it, you take these guys to the other side, which I will do. Your K, did I get it right? Yeah, 213 7 4 5 5. All right, so this is it. These are the 10 questions. Not really a hard exam, but requires you to stay focused. All right, so now let's get ready for the next exam, which is coming to us in no time. You know, like the final exams will be quickly coming to us. So let's get prepared, because the final exam will be cumulative, and they'll ask questions about material from the earlier two